All
Hey
right.
everyone. Oh, go ahead.
All right, welcome to the CS Education Zoo, everyone. This is episode number 5, and I'm here. I'm Steve Wolfman, and I'm here with my co-host, Will Bird. Will?
Hello. Welcome to episode 5, and we have a special guest today, a personal friend of mine and expert closure hacker, also someone who's been very involved in computer science education in sort of a different way than some of our previous guests, and less academic way, but in a great way in terms of bringing in or trying to extend computer science ideas to the programming community, the hobbyist community, the artistic community, and so forth. Um, so I'm very excited to have David Nolan here, who, in addition to being a fine programmer and a fine teacher, is also a musician and has a background in film, and hopefully we'll learn about all those sorts of things and how he learned to become so multifaceted, and maybe how that's affected his outlook on computer science teaching and learning. All right, without any further ado, welcome David.
Hello.
Hi. So do you want to just give a kind of brief background of how you got into programming, or maybe what you do now that you work for Cognitech? So sort of how did you, I know at one point in time you were a film student at NYU, is that correct, at ITP?
I actually studied film at UT Austin. I did an undergrad in film. At one point, I thought I was going to be a filmmaker. I ended up liking playing music more. But as far as like the computing thing, I mean, my parents bought a computer like in the late '80s. It was the Apple IIgs. My brother and I programmed BASIC, you know. So we were really into programming. And we were programming games since we were little, and then I got to film, and then I don't know. In the mid '90s, to me, computers were very boring. When I was in film school, I was very bored by them. Somewhere towards the end, I mean, it was really funny because I'd lost interest. But it was really like when Apple started sort of refreshing the design of computers, and the internet started happening. I was like, well, maybe this internet and this computer thing is interesting to me again. I didn't actually really get into computers until I came to New York. I got a degree in new media at NYU, at Tisch, and I ended up sort of refamiliarizing myself with programming. And then I got a job, typical PHP, Java, JavaScript type thing. And I've been doing programming professionally since, I guess, past almost 9 years, professional programmer. But before I became a professional programmer, I spent a lot of time when I was sort of teaching myself, refamiliarizing myself with programming. I used the structured interpretation of computer programs as a sort of way to get back into it, and I didn't know anything about Lisp. And so that sort of experience sort of shaped my interests as a professional developer.
So is that what led you to your interest in Clojure?
Well, when I encountered SIGP, I was like, this is really awesome. This is really cool. But I didn't know anybody that was using Scheme. So I was like, okay, that's like the most amazing book I've read. Like, it's up there with like, great works of art that I appreciate. I was like, this is an amazing book. But I really didn't see, I had no, couldn't figure out where people were actually using this stuff. So I sort of set it to the side. Then I was in New York, and I was working for 3 or 4 years working for Princeton University and some startups. And then around this time, I had like a break. I decided to take a summer off. And I recently become familiar with sort of Paul Graham's essays on Lisp. And there was a small but sort of excited community of young programmers around Lisp. And I was like, well, maybe I should look at Common Lisp and look at Scheme. I thought Scheme was cool. I thought Common Lisp was cool. I spent a lot of time with Common Lisp that summer. Common Lisp at the time was kind of hard to set up, though. So I got kind of frustrated with that. It was like not a great development experience, especially if you were coming from a Java, Python, or Ruby background, where there's, because of the size of the communities, there's fairly good tooling available. Wasn't true for Common Lisp. Around that time, I sort of heard of Clojure, and Clojure, I sort of jumped on it simply because it was a jar, and I could download the jar and I can start a REPL. And that definitely wasn't the case for, compiling and installing SBCL. It's easy now. It's easy now, but it wasn't easy in the summer of 2008. So I ended up jumping on the Clojure bandwagon. It was also, I liked Clojure because when I was at ITP, people were very big on processing. The processing is this sort of like interactive computing environment that sort of emphasizes, building sort of interactive art. And Clojure was interesting because it had seamless JVM interop, and some of my first experiments were just like live coding interactive applications with processing. And that was really cool to me because you can't do that with processing out of the box. It doesn't really support live eval the way that Lisps traditionally do.
So I know you have degrees in film and new media. Do you have any formal experience in computer science, or did you take any classes along those lines, or are you mostly self-taught as far as that goes, and reading books and papers?
I would say reading books and papers. I also think that like my background definitely, almost all the work that I have done professionally is around UI programming, and UI programming is more art than I think science, and always has been, and probably will continue to be for the foreseeable future. It also sort of jived with my sort of visually oriented interests. Sort of interaction programming, UI programming, and I think in UI programming you don't encounter quite as much, in many cases, the need for, deep insight into PL or data structures or anything like that. You can get by without that stuff. Though it's definitely useful. Not to say that it's not useful. I've later come to realize that those things are extremely useful. But I think you can get pretty far without knowing that stuff if you're doing UI programming.
Okay. And yet, of all the people I know, you're someone who is probably one of the most passionate people about reading academic papers and trying to read books and trying to understand ideas and programming languages and share those with other people. So how did that come about? Was that just of personal interest from doing things like reading SICP, or did you realize at some point that these ideas really were powerful to you, or was this like how did you get to this point? Because I also know lots of people who do UI programming who aren't as interested in sort of fundamental PL concepts and that sort of thing.
Right. So maybe it's hard to tell. So I've been doing, for me, it seems like, okay. So one thing I liked about SICP, one thing I liked about SICP is that I had done some C and some C++ and some Java, and I sort of always looked at programming languages from the perspective of a consumer. Like, I've received this programming language on a stone tablet from the heavens, and I really didn't think that programming languages are fundamentally ideas that people designed and created, and they're flawed in the same way that all sort of human endeavors are. But SICP was really eye-opening because a lot of things that I thought were really complicated and really sophisticated, like there's no way for a mortal to understand. SICP really shows you that no, objects, you can actually model objects very quickly, and actually. Some of the most powerful abstractions that are available are actually incredibly simple. At least getting the simple thing working is not hard. And then when you get to the metacircular evaluator, where you're sort of building an interpreter for the first time, and you're sort of are building your own programming language, it really changed my perspective on, I think, on what I thought the activity of programming is. And it also, I think, showed me that there's a lot of history and there's a lot of context, and often people are just sort of, again, blindly receiving these ideas without realizing that with almost anything in computer science, there are many ways to do things, and in fact, by exploring the alternative sort of solutions, you can guide yourself to a better solution. That's something else that I learned over time. Yeah, I mean, I don't know. My interest in CSE stuff is definitely based on my frustrations with programming in general, right? Like, you work on the same problem enough times and you think, there's got to be a better way to do this. Somebody must have thought of it. You know?
Definitely. Well, I guess we could also talk about some of the programs you're known for, especially in the Clojure community. There's your work on Core Match, it's very nice pattern matcher, which I know some of those ideas you took from some academic papers and ended up in Apple's new Swift language, and also, of course, you did work in CoreLogic, and most recently you're doing work in Core Async. Do you want to just briefly talk about those projects, and then maybe we can talk about some of the educational things that you've been interested in that I think are very interesting?
Yeah. So I think that's another cool thing about Lisp is that Lisp systems tend to be simple. I think it's just a benefit of the idea. Lisps have very little syntax, so actually getting into sort of like what would normally be considered very sophisticated types of programming are actually not hard in Lisp. Like, so with the core match stuff, the pattern matching, people see that as sort of a black art, but really in a language like Lisp where you have macros, writing a pattern match compiler, you don't have to worry about syntax, you don't have to worry about parsing. You really can take whatever match syntax you want to use and you can expand it out into Lisp forms that you need. So it was great. So when I did core match, people were like, I can't believe you figured all this stuff out. But it was beautiful. In Lisp, it was like I could read the original paper, which was aimed at OCaml community, or sort of the typed functional programming community. But the algorithm was very straightforward. So it was easy to port. There's a few obstacles in my path. I think similarly, that's why I was attracted to Mini Camerons, which is the system that Will and Dan and Oleg came up with, which is a really amazing sort of embedding of relational programming into Scheme. And same experience. I got the Reason Schemer, and then when I went through the whole book. It took me like 3 months to get through that book, and I was like, that was like one of the hardest things I'd worked through, and one of the coolest things I'd worked through. And then I was really sort of pissed off at the end when I saw the entire implementation in 2 pages, and that's when I like hunted down Will's dissertation. And again, that was like another sort of like aha moment that Lisp is a really cool place to explore ideas. I think it has a nice, simple set of tools, and you can really focus on the core ideas and not get distracted with extraneous concerns.
And what about Core Async? That's sort of the newest thing you've been working on, I think, right?
Yeah. So I've been doing. I actually don't. I sort of with Core Async, what I did was mostly make sure that it works well with ClojureScript because I'm the sort of lead maintainer on ClojureScript, which is a compiler from a very large subset of Clojure to JavaScript. So I work on the compiler as well as the standard library. So when I worked on Core Async, it was mostly ensuring that we would be able to get the same CSP semantics in the browser as well as get good performance in the browser. But Core Async is really cool. If you haven't heard of it, it's basically Tony Hoare's like abstraction from the 70s. We've taken that abstraction, we've borrowed some ideas from concrete implementations like Google, Rob Pike, who was at Bell Labs. He has had a variety of CSP-based languages. The most recent is Go, which is actually making waves in the sort of mainstream programming community. And it's actually a fairly, in my opinion, not exciting language. But the cool thing about Go is that it's getting a lot of people familiar with CSP.
So what is CSP?
Communicating sequential processes. So that's Tony Hoare's abstraction for reasoning about concurrent, like independent processes and how they communicate with each other and coordinating between them. So it's a concurrency abstraction. Because I mean, maybe to backtrack a little bit more, all the problems that we have today were known probably in the years between 1960 and 1970, right? So people knew that locks were horrible. People knew that shared memory parallelism with mutable data structures was terrible. That threading was too low of an abstraction. Mutexes are too low level of abstraction. So CSP was born out of the realization that we needed higher level abstractions. It has not. It's kind of exciting now, largely due to Go and Core Async. I think a lot of mainstream programmers are becoming aware of its utility. And what's really cool about it, the coolest thing about CSP, which I like, it's actually, I think, something that's not obvious in Go, that I think Clojure really drives home, is that CSP works great for concurrency, regardless of whether your programming language environment is single-threaded or multi-threaded, right? That's what's so awesome about CSP, that it gives you a way to reason about concurrency regardless of whether you have real threads or not. And that's borne out in ClojureScript, which I think is pretty cool.
Okay, well, yeah, so you've been working on these very cool projects, and one thing that's interesting to me is that each one of these has interesting ideas behind them, right? It's not just hacking, like they actually have interesting computer science ideas that are pretty fundamental. So getting into your educational activities, so a couple of things I know that you've been involved in. You've probably been involved in more things, but obviously you've been very actively involved in the Clojure community, giving lots of talks there, for example, and trying to bring the academic and computer science and industry and practitioners together. You've also been very heavily involved in Hacker School. Maybe you could say a little bit about that and why you think it's interesting and cool. And also, I know you have something more recent called Kitchen Table Coders. So could you talk about some of these educational things you're doing and maybe your broader perspective on these projects and why those are interesting or important to you, and maybe how does your viewpoint maybe differ from more traditional academic computer science education?
Right. So I think maybe my style is sort of informed by my experience at ITP, the Interactive Telecommunications Program at NYU. And it's kind of interesting what they have going on there, where they it's a new media program. They get like architects and artists and writers and playwrights and actors and just a random assortment of people, many which don't have any programming experience at all. Also, people do a lot of physical computing there at ITP. It's that's very popular. And so what happens in an environment like that, where you don't have a broad base of sort of experts or a lot of expertise around the technology, is that people have to teach themselves. In fact, if somebody acquires a bit of knowledge, it's really useful to share that knowledge, because often by sort of having this culture of sharing stuff, you'll often learn something in return, right? I'll learn about, I'll show somebody something about programming, and they'll show me something about how to program Arduino. And what I've learned, or my experience, that experience showed me that it's really important to have these learning environments where, I don't know, people mutually benefit from shared knowledge, especially if that, again, different kinds of information. And then when I ended up teaching there for a long time, probably for 3 years, I was a adjunct, teaching various topics, whether it was programming or more sort of like, art-oriented yet still technology-based stuff. And I like teaching. Teaching is fun. I mean, I feel like teaching is a great way to learn. Like for me, it's awesome, more fun, because you get to learn new things yourself. And so that experience sort of informed KTC, which is Kitchen Table Coders. We occasionally run workshops here in this studio. It's very small. We like the group to be small, because I think in general, we prefer that the experience be very hands-on. And the only way to really get things to be hands-on is if the class size is quite small. And we run 4 to 8 hour workshops on a variety of topics. A lot of them, programming or art or science related in some way. On Hacker School. Hacker School. So Hacker School is interesting because Hacker School was started by 3 people. One of them was this lady Sonali, and we were actually in the same class at ITP. And I think the ITP sort of open learning sort of philosophy heavily influenced the design of Hacker School. And I was invited there a couple of times as a resident and as a guest speaker. And I think it's great. And they sort of took the ITP idea where people are working on lots of things and sort of narrowed it down to the practice of programming. But the practice of programming is a pretty broad topic, so it still works.
Can you briefly explain sort of what Hacker School is or how it works and how it's kind of not a school?
Right. So Hacker School is more like a writer's writer's retreat, but for coders. They run it now. I think it's like a little bit complicated, but they run batches. People apply. It's based in New York City. At one time, I think they have about 70 students, at one time, and they have several facilitators. And it's really an environment in which people teach themselves to code, and they teach themselves programming language concepts. And it lasts 3 months. It's great, and they do a really great job of getting both people who don't have a lot of background, as well as people who've already graduated with CS degrees, who have a lot of industry experience. And when you get everybody to the same room, it kind of makes for a great environment. I sort of definitely believe in when you have a diversity of experience, it ends up being a lot more fun.
Well, very cool. I've got a zillion other questions I could ask, but let me give a chance for Steve to jump in here. Steve, do you have anything you want to ask?
Yeah, I'd love to. I got a couple queued up. I was excited to hear your fire hose of questions too, though. That was great. So, David, let me start with the most recent thing you mentioned. So, you said that Hacker School is a place for people to teach themselves how to code, to learn how to code, and also to learn programming language ideas. And I'm kind of curious, it sounds like to you those two things are one, and certainly that fits with the SICP perspective. But there's lots of people who learn to program and they don't learn any what we might think of as programming language concepts. So why do you see those as entangled? Why is it important that they are together?
Right. So, I mean, my experience is that having worked in the industry for a long time, is I actually think that the problem of programming languages and the various activities that real-world engineers engage in are not really separate, right? I mean, if you look at the way that people design APIs or the way they design libraries, you're always encountering problems around language. It's just that you're just really talking about at what level of abstraction. And I think it's really extremely important that people that are getting into programming language, that they see that. I mean, you don't want to throw too much at a young programmer. Like often with very inexperienced programmers, you maybe want to stick with one language, stick with the basic concepts. But I think it's important to say at the back, keep it in their to remind them that there are other languages, there are other approaches, there are other abstractions, and this is one very particular approach. And it's just really a peephole into a much bigger world. And I think it's just a good way to keep things in perspective.
So would it be fair to say maybe that the importance of programming languages for programmers is that learning about programming languages is a way of focusing on the idea that we're always trying to take what's in our head and say it in a way that is realizable, and programming languages are about understanding the different ways to say the things that we're thinking?
Yeah. For example, I mean, very few people program in assembly. It's just a simple example, right? It's very difficult to reason about code at the level of assembly. It's just too far below the concerns of the programmer. But as it turns out, that often is the case, right? You're a web programmer, you're a JavaScript programmer, and you're doing web browser stuff, and you quickly encounter this problem where you're like, the DOM, the document object model, the fundamental abstraction of the web browser, it's just too low level. It's not a good place to reason about the system. But you really encounter this in programming languages as well. There are good constructs. Every language has constructs that I think are good and things you should reach for all the time. And then there are constructs that you're like, well, maybe I really should avoid that one. It's useful in a much narrower set of cases. And I think you encounter this all the time. In mainstream, people call this best practices, right? Like, I don't know. I hope that answers your question somewhat.
Yeah, I think so. All right, so then let me jump way back. You said something that really intrigued me earlier, which was that computers were boring in the mid-'90s. And I'm just kind of I'm curious to poke further at that idea. What was not boring? What was exciting about computers before, and what was boring during that, and what made them exciting again afterward?
Well, I mean, I think when you were young, if you were young, I mean, the personal computing revolution really started taking off in the 80s, right? In the late 80s, it was a lot of people had their very first computer. You were surrounded by people who had their first computer. Families had their first computer. So it was very new. By the time you got to the 90s, people were on their second or third computer. And except for the fact that your games looked cooler, I mean, what people were doing with computers was more or less the same. It didn't really change until the internet came around. That was pretty interesting. But around that time, you also had, and Java is fine. People write interesting software systems with Java, but Java sort of took over, right, in a very big way, and probably for reasons that made sense. It was a programming language that shipped out of the box with some basic ability to run in multiple places, basic facilities for talking over networks, garbage collection. The fact that it shipped with a garbage collector was radical at the time. It was very unusual. And it's sort of for 10 years, I really felt like that Java was the only game in town if you were going to be a developer. In fact, I mean, when I would hang out with my CS friends, I mean, CS seemed like Java vocational, training. But it's changed. I mean, I think we've come around, right? I think with the recent interest in functional programming. And new languages, it's been awesome. I mean, I think it's great. We're slowly inching towards something else. I would say that things like Go and Swift are incremental steps. Even something like Clojure is an incremental improvement over the really big Lisp ideas. But at least we're heading in a different direction finally.
Okay. Thank you. Will, you want to take the next one? I've got some more,
Sure.
But I'm sure you've got.
Sure. I guess as a follow-up to that, one thing that's happened to me, I too have been programming for a long time, and one thing that would happen is at some point, I don't know, I would feel like I had the knack for certain things, and it would become less interesting to me, and then I would discover something totally different, like functional programming. It's like, whoa, I don't know how to program anymore, right? This is kind of interesting because now I get to relearn. I get to be a newbie again, right? And the same thing happened when I discovered logic programming, and or term rewriting systems, or the other systems or languages or paradigms, right? So do you think that was also part of it? And do you think that's one reason that programming languages are important for education for programmers, is that it gives them a chance after they've been programming for a while to sort of force on them by picking a new language that, hey, there really is a totally different way of doing it. And if you think you really know how to program well in C and that's all there is to it, try writing some Prolog programs, and then you're going to have an attitude adjustment, right?
Yeah, I definitely think it's important, though. I think that's I think it's trickier, though. I think so. You have a. I will say, like, if you take existing programming practice in the industry, I mean, a lot of the things that people are doing are actually extremely sophisticated. When you look at like the types of systems that are being built at big companies with what I would consider like not very sophisticated languages, okay, maybe their approach is bad, but in the end they are building very sophisticated systems. Extremely sophisticated distributed computing, very extremely sophisticated concurrent systems. I mean, people are doing amazing stuff given the sort of limitations of the material that's being used to build these things. And so there's a challenge. I think with functional programming, with relational programming, with these ideas, I think the important thing is really to show people how it simplifies the problems that people already understand, right? And I think that's the big challenge. And a lot of times when I explore concepts myself, I'm always looking for, okay, this is really awesome. Let me see if I can figure out where I can actually where this lines up with a problem I had in a more traditional setting. Does it simplify solutions in that more traditional setting?
Absolutely. Okay, so changing track a little bit, could talk about some educational things again. One thing that I think you have a reputation for is for trying to interest people in industry and hobbyists to look at some work in academia and to read papers. You get a very nice keynote talk at Strange, I think it was at Strange Loop last year, about how practitioners should read papers because some of these problems have already been solved and so forth. Can you talk a little bit more about how you think we could improve communication between industry and academia, or are there better ways that we can improve that coordination, and are there ways that people learn in industry that you think people in academia could learn from, and vice versa?
Well, I mean, I think that's an interesting problem. I mean, some of these things, it's hard to see, right? Because you can't. There's some things that's impossible to predict. A good version of this is actually, so the most recent thing I've actually worked on is not these closure and ClojureScript libraries, but it's this library I wrote called Ohm, which is it's an abstraction over Facebook's React library. React is it's a sort of UI programming framework for the browser. But what's cool about React is that it adopts it's like a graphics pipeline approach. So if you do any serious amounts of computer graphics programming, you have this problem in which you have the GPU, but the GPU it's distant, and you need to basically prepare all your information in order so that you can send it to the GPU in one swoop. You really can't have too much communication with this remote service. And the benefit of actually doing it sort of this batched rendering is that you get incredible performance, right? So the reason games look so great is because people have simply adopted this model where you have this extremely specialized hardware architecture, and you have to speak to it in a very specific way. And it's actually very functional. If you looked at like hardcore graphics programming, it's actually functional programming with really horrible syntax. So React works this way. It's like an immediate mode rendering system. And something that I saw when I encountered it, which was sort of suggested to me by my friend Brandon Bloom, is that you can actually make their system faster with immutable data structures. Right? So this is like a very, very non-obvious thing. In fact, you could probably look around a lot and not encounter anybody coming to this conclusion that you could actually write a virtual sort of, it's basically a virtual DOM representation, and you can actually drive their diffing algorithm with immutable data structures, and you can beat imperative solutions. So that's the cool thing about React plus immutable data is faster than what people are doing by hand by talking to the DOM directly. And that's something that you really can't encounter without simply saying, well, I think immutable data structures are cool, I like programming with them, and then some other piece of technology just happens to appear, and then you have a realization, and then you have a very interesting solution that's actually extremely applicable and easy to communicate to mainstream programmers. So I think, again, the question isn't like, how do you convince people to just look at research or just look at mainstream practices? Again, I think it's a problem of diversity, right? If you have enough people with enough broad base of knowledge, you have the opportunity to connect the dots, right? It's not like engineers can immediately see how to apply science or academics immediately understand the problems engineers have. I think you have to have a culture in which both parties are aware of the problems and the approaches, right? I mean, that's been my experience.
So that's something that you see in Hacker School when you have people from different backgrounds showing up, and it's something that you can see, I guess, with industry consulting from people in academia, or maybe industry internships from students. Are there other ways to try to make this happen, or should more people in academia, be doing consulting with industry or trying to look at these industry problems, or do you think it's okay? Do you think it's happening enough, and it's just one of these things that you can't really force it anymore? People will figure these things out, or do you think that people in academia, for example, do people in academia need to find better or easier ways to make some of these ideas understandable, or do you think the resource sources are already out there?
Well, I still think it's a problem of communication. I think if you have academics, if academics take sort of engineering concerns more seriously and look into how people, and also sometimes there's often missed opportunities where you have a community of practitioners applying a thing, but maybe the researcher isn't even aware that their research is being applied, and in fact that their research should probably be slightly modified because these people put the basic ideas into practice, and maybe some things about the model needed tweaking. I think that happens a lot, but I think it's just an awareness issue, right? I don't know if there's anything other than I think both groups just need to pay more attention.
Gotcha. Okay, well, I could follow up on that, but Steve, do you have anything else that you want to ask, or I'm trying not to hog all the time?
I've got my usual, and we've got a couple of questions queued up from our audience. So should I ask one of my stock ones, and then maybe we should go for an audience question? Or?
Yeah, sounds good.
All right. There's a couple of questions I try to always ask, David. So one is, can you describe a teacher that you've had that you admired, and what you admired about that person?
Well, I mean, I've had quite a few teachers that I've liked. But I mean, it's a bit of a weird question because I learn things from a lot of people. I mean, I feel like, everybody's a teacher, really. I mean, I don't think I've acquired any interesting idea. There are very few ideas that I could call my own. Let's put it that way. I've mostly learned things by synergizing ideas that I've received from other people. What was the other? Was there some other part to that question?
Well, just to pick someone that you've learned a great deal from, or that was really influential on you, and to say why they were important, what made them important to you.
It's really hard for me to pick one person. I don't know if I have a good answer to that question.
Were there any mentors that kind of took you under your wing when you needed some guidance and helped you out?
I mean, it's just such a long list of people, right? It's like I can name people from every year since I began speaking that have been mentors and guided me to where I am today. It would just spend the rest of the CSS Zoo thanking people.
I can see this is like the ITP way, right? Where it's like everyone's just always collaborating and.
If you'd asked me, 3 years ago when I first met you and Dan, I mean, that was like an amazing moment. I was really excited about relational programming. I was totally in the weeds. I had no idea. Being able to speak to you and email with you and like meet you at conferences and talk to Dan and see what you guys are working on and really and like get sneak previews of research that you haven't published yet. I mean, these are all. That's like. I mean, there's nothing better than that, and that's definitely, yeah. I feel like at different points in your life, there's somebody you're like, I'm so glad that they were there to help me at that moment in time. Hopefully that answers your question.
That'll do. So, Will, do you want to take one of our audience questions?
Yeah, sure. Well, I also just should point out that I guess it goes both ways because David always has this very refreshing point of view, right? And I like David's attitude very much that there's always more than one approach, and I think in academia especially, it's very easy to get really focused on, hey, this is the right way to do it, or this is really cool, or this has very beautiful theory or math, and very easy, I have to kind of resist myself from bashing on Java or whatever. And David's always very good. It's like, well, there actually are multiple ways to do this, and each one has its advantages. So I definitely appreciate that. I feel like I've become less closed-minded every time I talk to David. Okay, so an audience question here. I will start with Julian's question. We're seeing the rise of types in functional programming languages like Haskell and Idris. Now SQL has grown out of Datalog from Prolog from Lisp. Do you see a future for types in making SQL equivalents more robust at compile time and easier to refactor? I guess this maybe is less of an education question, more like a future of programming question.
Right. I mean, I think that I think types will continue to be important. I think there's tons of interesting research, especially of particular interest to me is the gradual typing stuff, because that's sort of trying to bridge the fact that, I mean, there is the things like Haskell, which really have not broken into the mainstream, the sort of like ML-derived approach to types, which is extremely powerful. The kinds of guarantees that those systems can give you is like pretty amazing. To some degree, I think Scala has had some luck bringing that to a wider audience. But I actually think that probably the more fruitful thing will be bringing types to, or allowing people to overlay types over what are traditionally dynamic programming languages. I think there's a lot of interesting work to do there. But I actually don't think it's really a question about just types. I mean, I think a lot of the research around contracts, verification of contracts, and even like some of the most interesting stuff is where people have to contract from code itself. Like you basically write regular code, and then through analysis, they're able to detect invariants and verify them, or point out inconsistency. I mean, it just seems like a lot of things in CS, there's a lot more to learn, a lot more work to do.
And I think that kind of covered Dan's question as well, Will. Dan's was sort of the abstraction of Julian's question, and that's where David went, I think.
Yeah, that's right. So Dan's question was, where will programming be in 5 years? So I guess I can ask the educational equivalent, especially with things like concurrency and parallelism that aren't always taught to beginning programmers, right? They're still seen usually as more advanced concepts. What would you like to see, or where do you think we can go in sort of computer science education and teaching? And do you think things like parallelism and concurrency, abstractions, things like CSP should be taught earlier? And are these ideas actually not that hard, and we just should show people earlier and not treat them as so hard, and people just get used to it?
I mean, I think there is some utility in. It's definitely a good idea to talk about CSP. I mean, I definitely think that in the case of like education. I think it would be great if more programs talked about the actor model, they talked about CSP. And also, you know, these systems have problems. And in fact, they're very big systems that use the actor model. You can look at Erlang and really hear, like, where does the actor model fall down? You could probably ask in a couple of years a professional Clojure programmer, and they would say, yeah, QuerySync is amazing, but it has these problem areas. One of the biggest is deadlocks, right? And so something, if you look at the old research around CSP, I mean, so much of verification of CSP system was automatic detection of deadlocks. So that's huge. Like, if you could take a deadlock detection and apply it to a Go program, apply it to a Clojure program, I mean, there's a lot of interesting research that's been done that could probably be further refined. Also, you have another cool academic thing called QuickCheck. QuickCheck is this sort of generative testing thing, but it has this really cool property in which it finds a minimal sort of searches a space and finds a minimal set of steps to construct a failure. And they've just started down the path of using it to test concurrent systems. And how they do this is by taking your program and then by substituting a scheduler into QuickCheck. QuickCheck can actually be used to detect things like race conditions and deadlocks in a probabilistic and generative fashion. Super cool. And again, that's like those two things I just described are direct bridge from research to fixing the program that I'm writing today. Tons of opportunities, I think, there. Again, with types, like, I think bridging dynamic languages and type languages, I think, is going to be huge. Data structures, I think with Clojure, right? Clojure and Scala and Haskell have shown that, like, these persistent data structures really deliver amazing performance. I don't think we've seen the end of the types of optimizations that are possible, or the types of data structures that are possible. Data structure research tends to be pretty slow, right? It's really hard work and requires a lot of both math and then, like, a lot of empirical research, right? And of course, programming languages. I mean, I feel like as we build more sophisticated systems, we want more from our programming language. I definitely think as the types of software that we want to build becomes more sophisticated, we'll want to augment our languages or move to entirely different ones.
And I guess sort of the last double education question is, what other education or teaching or learning related initiatives or projects or ideas do you have that you would like to play with? Obviously you've got the Kitchen Table Coders. Are there other things along those lines that if you had more time or resources or one day you'd like to get to, you'd like to try? And what are the things you've learned from all of these educational and learning and teaching activities?
I don't know if there's anything else I would like to try, but between going to conferences and doing Kitchen Table Coders and doing these blog posts, I think that there is a large group of practitioners who want to find better ways to build the systems that they're building, and often they just need a small, like, bit of inspiration so that they can understand the concept without having to read a bibliography and read 100 papers, right? I mean, I'm a big nerd and I don't mind reading all these things, but it's kind of like unrealistic to expect that everybody else will or want to. In fact, it's not important that they want to. Often what they want is that, like, I see that you have an interesting idea, but show me how I can use it, so that they can show other people how to use it. I think that's been for me a really big lesson that you can say this is a constraint solver, and people they have no idea what you're talking about, and then you show them a very short program that solves their problem in a very tiny amount of time, and it's beautiful and it's declarative, and then they suddenly get very excited and they say they want to know how it works. Yeah, I think giving people tangible applications, and spending time, like the pedagogical side of that, taking a very sophisticated idea and making it, sort of presenting in a way that anyone can understand it, or somebody with at least a basic amount of experience in programming can understand what you're talking about. It's been really rewarding to see people respond so positively, blog posts and my talks about what I thought were pretty esoteric or crazy ideas, and people really say, no, this is awesome. This is you've explained it to me, and I think this is a good way to write software. That's really cool.
Thank you. All right, Steve. Do you have anything you want to ask?
I've got a few more questions. I just want to check in on our time. Do we need to ask for shout-outs before we finish? How are we doing?
So we started a little after the hour, so I think we can go for one or two more questions.
All right. So then I'm going to start with my other stock question. Get them both in. What's something you think every computer scientist, every programmer should read or learn or do or play with? Some experience they ought to have.
I mean, for me, you know, definitely it's I'm biased, but like, you know, I definitely think that you should read SICP. SICP is totally awesome. You know, now that I've played around with Prolog, I think that almost everyone should like pick up a copy of something like The Art of Prolog. That's something I think that is not enough people understand the benefits of that approach. I also think that like I actually think having a good grasp of typed functional programming is also extremely useful. There are lots of cool ideas. I think Haskell, I mean, I don't have that much experience in Haskell, and actually Haskell has a few good educational texts, but I've also found Standard ML to be a really nice introduction to typed functional programming, especially if you have experience in Scheme, because Standard ML feels like Scheme with, like, you know, different syntax and types. Yeah, I think those. I mean, I have such a huge list. I mean, I would be like Dan. I really like Dan and Mitchell Wan's book, The Essentials of Programming Languages. Like, I feel like the Lambda Calculus, if you read like a book, like I have this book right here. It's by the Lambda Calculus and Combinators, an introduction by Hindley and Selden, and it's. I mean, you have to be pretty serious to read this, but you can read The Essentials of Programming Languages, and it really, that book explains the Lambda Calculus, and it's hands-on, right? It's like you get to type the Lambda Calculus into your computer. Like you get to touch the Lambda Calculus. So I think books like that are really great. I love computing because computing is a way to like make a lot of these abstract concepts tangible. I think maybe hopefully that answered that question.
It did. Will, do you want to take the next one? Sorry, I'm writing down notes of things that I like. That's why I keep looking over here.
Okay. Actually, I have that Hindley and Selden book right next to me. I bought every book on Lambda Calculus that I could find on Amazon. Anyway, well, yeah. Anyway, well, I guess, are we getting close to shout-out time, Steve? Is there anything else you wanted to ask before shout-outs?
I've got a bunch more questions, but I feel like we could go on forever, so we should...
Okay, well, how about one more question, and then we'll do shout-outs. So I'll leave it to you, Steve.
All right, okay, so it's mine. Let me look over my list of questions here. So, as you've been talking, I get a sense that you have a very strong aesthetic sense of what it means for a program to be a good solution and a beautiful solution. And I know it's way too big a question to ask what makes a program a beautiful solution, but I wonder if you could just sort of explore that idea a little bit. What makes it so that a solution, a programming solution, fits the problem?
So I'm a strong believer that you can't know that something's a good solution until you know at least two solutions to a problem, right? You can't really know that something is good or bad if you haven't at least tried to solve it at least 2 ways. So yeah, I think the aesthetics often boils down to having done it one way and then having tried it in an alternate way and seen the trade-offs. And then I think that you have the case where maybe you've tried it 3 ways or 4 ways. And then I think you get closer to like, okay, I see that one of these ways is really nice, and the other ways weren't so nice. But I don't think you can even get started on that path without having at least tried 2 ways of doing something.
That's good. So do you feel like is it always worth it to try 2 different ways when you're solving a problem?
So I was thinking about that when I gave that answer. So I think the challenge is that you often encounter you don't have time to try solving things 4 different ways, and that's why I think teaching is so important, right? The whole purpose of having a teacher is somebody who has experience, who has seen 4 different ways, and in fact they can actually, like, one of my favorite things is you have a really great textbook and you have a series of exercises and they're small enough and you can try a couple alternatives, and you at least get some sense of how they might be different. And then with, if you take on a larger problem, you can see some of those benefits. But still, I think the thing is having people who have tried it a bunch of ways, and then those people communicating the trade-offs is extremely important. I think a big part of education, because you need filters, right? Because not everybody has the time to do all that research.
All right, thank you. Those are great thoughts for the 2 minutes we had to talk about them. It's awesome. All right, Will, I'll give it to you.
Okay. Yeah, sure. Well, by the way, just Dan Friedman, whenever you work on a book with him, his view is if you ever have a doubt of how to write a chapter, you write it both ways, at least, maybe 3 or 4 ways, and you throw out all but one. It's a lot of work, but it works. It's good.
Yeah.
So anyway, so usually at the end we just ask, are there any shout-outs or anything people you want to thank, or resources you want to point to, or people want to learn about kitchen table coding? We can include a link to that. But is there anything upcoming with that you think people would be interested in knowing about, or talk about your blog or whatever?
I would say, I always like to tell people to check out your dissertation, check out the Reason Schemer. Check out the books that I've talked about. I don't know. Yeah, I would say read books, read papers, try crazy stuff. I don't know if I have shout-outs to that.
You can't give a shout-out to my dissertation. That'll look like you're a plant.
No, not.
Well, what about the kitchen table coders? So can you say a little more about how that works? Because I've always been interested. Next time in New York, I want to check it out. Can you?
Oh, yeah.
Can you just say a little bit about how it works, and has it changed over time, the format?
It changed a bit over time because we have more people. And we don't run them quite as much, actually, because we have more people. And so now it's been a thing where it's actually kind of back to how it was. We only run them when we're to some topic we're really excited about. I'll probably talk about React and basically show React from first principles. We've done a really fun one in the past on datomic enclosure. That's pretty cool because that's programming against immutable database. It's pretty interesting. We also run Code Salon. And Code Salon's really fun. We only do them. I mean, you should do one, and if you next time you're in town. But we invite random people to come, and the audience is 10 or 15 people, and it's like a salon. We would just sit around. Somebody talks about something that they're working on, and there's a lot of. It's mostly almost entirely QA. That's a lot of fun. We end up learning a lot there. We had the Elm guy show up. We also had the guy, one of the F# developers who worked a lot on type providers, which is really cool. It's sort of this really interesting approach to typing external resources, which is a kind of a hard problem if you're in a typed context because the entire world is not in your programming language, and that's a challenge. but yeah, it's a bit of a free for all. You know, we kind of just do what you know, whatever sort of happens, whatever we think is cool at the moment. We run either a talk or a workshop on that thing.
Well, that's fantastic. And you're still continuing work with Hacker School, is that right? Are you like you're like a meta level person with Hacker School? You were, right? Where you were like
yeah. So I haven't been doing as much recently because I was at the New York Times for 4 years and I was plenty busy then, but I really wanted to help out with Hacker School, but I've recently switched jobs. I'm at Cognitect, and I've been pretty heads down recently with Cognitect projects, so I haven't had quite as much time to poke in over at Hacker School. But they're doing awesome stuff. A lot of my friends, people I know, I like, get this person to go speak, and they go speak. You've been there. I think Nada Amin's been there. My friend Amit Pataru, who's an artist and sort of musician, he's going there pretty soon. Yeah.
Well, I love seeing all the creative approaches you have to teaching and learning, and looking forward to seeing much more of it. And looking forward to seeing you at ClojureCon.
Yeah, it's gonna be fun.
Yeah, we're gonna have the Scheme Workshop there. So once again, another effort to try to get the academic folks and the industry folks and hobbyists talking together. I love that. All right, well, thank you so much, David. Steve, is there anything else you want to say before we end?
Just want to say thank you and reiterate earlier. David mentioned he learns from a lot of people. He learns from everybody he interacts with, and I want to thank you, David, and all of our guests so far on the CS Education Zoo. This has been a great chance to learn from people with lots of different perspectives.
All right.
You're welcome, and thank you for having me.
Absolutely. All right. Well, thanks a lot, and we'll sign off. Anyone wants to stay around to chat, we can do so.